Space traveling, alien discoveries. Are you a space enthusiast too? How did they manage to find out the new star in a billion years away? I sometimes wonder if it's even real. In today's video, we will introduce space telescopes in detail with new discoveries. But first, let us explain the most commonly used word in space: light years. A light year is a unit of measurement used to describe the distance that light can travel in 1 year. Light is incredibly fast and can travel at a speed of about 186,282 miles per second, 299,792 kilometers per second. Because of this, it can cover an enormous distance in a very short amount of time. A light year is the distance that light can travel in 1 year, which is about 5.88 trillion miles, 9.46 trillion kilometers. To put this in perspective, if you were to travel at the speed of light, it would take you about 671 million years to travel 1 light year. So, when we talk about distances between stars or galaxies in space, we often use light years as a way to measure them. For example, the nearest star to Earth, Proxima Centauri, is about 4.22 light years away. This means that the light we see from Proxima Centauri today left the star 4.22 years ago. A space telescope is designed to observe a wide range of electromagnetic radiation, including visible light, ultraviolet light, and infrared radiation. Space telescopes have several advantages over ground-based telescopes, including the ability to observe objects that are obscured by the Earth's atmosphere and the ability to observe objects that are too faint to be seen from the ground. One of the most famous and successful space telescopes is the Hubble Space Telescope, which was launched into orbit in 1990. The Hubble telescope is equipped with a 2.4-meter primary mirror and a wide range of scientific instruments, including a camera, a spectrograph, and a coronagraph. The telescope is able to observe objects in the visible and ultraviolet portions of the electromagnetic spectrum. The Hubble telescope has made many groundbreaking discoveries, including the discovery of dark energy, the observation of distant galaxies, and the study of the evolution of galaxies. One of its most famous discoveries was the observation of supernovae in distant galaxies, which provided evidence for the accelerating expansion of the universe. Another successful space telescope is the Chandra X-ray Observatory, which was launched in 1999. This telescope is specifically designed to observe X-rays, which are a form of high-energy electromagnetic radiation. The Chandra telescope is equipped with a high-resolution imaging detector and a spectrograph, which allows it to study the properties of X-ray-emitting objects such as black holes, supernovae, and galaxy clusters. One of the major discoveries of the Chandra telescope was the observation of a supermassive black hole in the center of the galaxy M87. This black hole has a mass of 6.5 billion times that of the Sun and was observed to be emitting a jet of high-energy particles. Another notable space telescope is the Spitzer Space Telescope, which was launched in 2003. Spitzer is an infrared telescope that is able to observe objects that emit infrared radiation, including stars and planets. The telescope is equipped with a 0.85-meter primary mirror and a wide range of scientific instruments, including a camera and a spectrograph. One of the major discoveries of the Spitzer telescope was the observation of exoplanets, which are planets that orbit stars other than the Sun. Spitzer was able to detect the infrared radiation emitted by these planets, which allowed scientists to study their properties, such as their temperature and composition. The latest space telescope of the NASA is the James Webb Space Telescope, JWST, which was launched in 2021. JWST is the successor of the Hubble telescope and is equipped with a 6.5-meter primary mirror, which is more than twice the size of the Hubble telescope's mirror. JWST is designed to observe a wide range of electromagnetic radiation, including visible light, infrared radiation, and submillimeter radiation. JWST is expected to make many groundbreaking discoveries, including the observation of the first galaxies that formed after the Big Bang, the study of the formation and evolution of stars and planets, and the search for signs of life on exoplanets. Despite the many groundbreaking discoveries and advancements made by space telescopes such as the Hubble, Chandra, and Spitzer, some argue that the cost of these missions and the maintenance of the telescopes is not justifiable. They argue that the money invested in space telescopes could be put to better use in addressing issues such as poverty and climate change. However, others argue that space telescopes are crucial in advancing our understanding of the universe and that the knowledge gained from these missions has far-reaching benefits for society, including technological advancements and economic growth.